Hello world, my name is Shithij, this is the coding tree, and today we're talking about files. So far, we've been learning about the input command, the built-in function in Python that automatically takes input in from the command line. However, that may not always be the case that you want. You might not always want to take input directly from the command line and instead from some larger documents. For example, in modern day programming, JSON, which is a type of structured text document, is becoming widely popular. With that, it's also important to recognize how to take input from files, be it JSON files or be it simple .txts. For this lesson, it's important to create a separate text document inside of the same file as your Python file if you're trying to follow along. In that file, make sure you call it test.txt or any other name that you will remember, and make sure it's a text file. Because we need to be able to access that text file through our code, and to do that, we need to know exactly where it's located. To simplify that process, it's easiest just to put it in the same directory as your Python file. Because the input command isn't necessarily the best option at all times, it's important to be able to open this file with our Python code now. So how do we go along with that? Well, it's actually another inbuilt function in Python. It's nothing too complicated. This time, the function is simply called open, which will open the file to be read or written to later. Although opening text files to access with Python code does seem initially scary, it's really not that bad. That being said, it is pretty different from the way we've been taking input in so far. That is, we can't just specify the input command, we actually have to do something within the command itself. There are actually only two functions with the open command. The only things you have to specify are the file name and what you're planning on doing with the file. Now, I'll get to the second part later. First, let's just write the file name and write the open command, and inside of it, write the file name within quotation marks because it inputs a string into the open function. So if we just write that, we are now accessing that file that I stored earlier. Now for the second part. Now, truth be told, you don't always need the second part. It actually defaults to reading the file and one other thing. We'll talk about that in a second, but first, let's just talk about the overarching things that you can do with these files. There are actually several different codes or just simple letters representing different information that can go for this second function. Those include reading a file, represented simply by an R, writing a file, writing to a file, represented simply with a W, appending to a file, represented with an A, and creating that file that's specified in the first parameter, represented simply by an X. For now, let's just talk about reading from the file. Normally, simply putting R after the file name as the second parameter in the open function is enough. There's actually one other case in which you will not want to do that, and that's when you're not trying to read text. When you're trying to read instead of text, you're trying to read binary data. What is binary data? Well, I've talked about it previously in another video, but what you can actually do with this is represent complex things like images or something else. That's why if you were to represent something like that, you would put, instead of just simply putting R, you would put RB. What that does is simply let the compiler know that we're not trying to read text, we're trying to read binary data. It does default to text, however, so usually you don't have to worry about that. Next, let's talk about actually the act of reading from a file. Now, using the open command on its own is not enough for our purposes. What you have to do is actually store the return value. Remember when I talked about functions in the past, the return value is what the function gives back after we put in the parameters. You have to store that value in a variable. What that does is simply store an instance of the file that we just opened in a separate variable. What we can do with that is everything we specified before. That means that if we were wanting to read from this file, we can essentially do that with whatever variable we just created. So now what that variable is actually turned into is an instance of a class, some random built-in file class in Python, and that class comes with its own commands. One of these commands is the read function. So we can simply do file name, whatever you stored that variable as, dot read with opening and closing parentheses because it's a function. And with that, we're actually returning back all of the text that was in the file as a string. We can then store that text in a separate variable, and for our purposes, we can even print it out to see if it's actually working. And it does. It prints out exactly what I just specified in the input file. Now I know this is just taking an input and printing it back out, but remember, we're taking it from a file. So we can do a lot more with this because we can handle a lot more data. So now I can read to a file. What about writing to that same file? Well, I actually need to open that file as not a file that I'm reading, but a file that I'm writing to. What does this do? Well, it allows me to change the contents of that file entirely. As you can see right now, the file itself specifies this. But I wanted to specify something completely different. That's when I use the write command. So simply by opening that file in a separate way, instead of adding the r as the second parameter of the open function, instead of that, if I add w, what that does is allow me to write into the file and change its contents permanently. So what I can do is f.write, what in parentheses after that, and then as my input to that built-in function, the same way we talked about the read function earlier, I can add whatever content I want. So I'm just going to add something random here and then write to that file. I'll run my code, but nothing will change in the file itself. Why is that? Well, Python is doing its job correctly. However, it's not doing enough at the very end because it's still thinking that you're wanting to do something with the file, and as such, it's not updating the file in the source directory itself. Because we haven't specified to the Python compiler that we are actually done working with this file. How do we do that? Well, after writing to the file, all we simply have to do is file.close. That will close the file, tell Python we're done with it, and update the file such that we can see it. But notice, before I wrote to the file, there was some additional data already present in there. What if I still wanted to have that data, and instead, with my Python code, just add to it? Well, that's where the third designation for the second parameter of the open command comes in. Instead of doing R or W, we write an A. What this specifies to the Python compiler is that instead of writing to the file and replacing everything, we're actually appending to the file, which means we're adding stuff to the end of the file. So now, if I just specify it like that, instead of overwriting everything, it's just going to write to the end. I don't even have to change the .write command. I can just keep it as .write, and it'll still write to the very end. That's why it's really important to understand the different ways that the second parameter of the open function works. Because with the write command, with the same exact code, I'm performing two entirely different behaviors. One replaces all of my content, and the other simply adds to it. One thing you might notice is that this code can actually be a lot more efficient. What's happening right now is that we're reading from the file or writing to the file or appending to the file. But in the second two scenarios, we're always having to specify at the very end exactly when we're done with the file. What if instead we could work with it like a function? That's where the with keyword comes in Python. With is a keyword in Python. What it does is allow me to run the open command, save it as a variable, and do anything I want with it, and then later automatically close that file. All on its own, with simply one line. The with command, what it essentially does is automate that entire process. So the way the syntax for the with command works is with and then open. So the open function specified exactly how you want it. If you want to write to it, write to it. If you want to read, you can read. If you want to append, you can append. That function, and then the keyword as. So as simply specifies that the next word that comes after. So here is the entire command, and the word file at the very end just means that file will be a variable that we are storing the file instance that we got as the return value for the open command in. That might sound a little confusing, but it's essentially what we've been doing in the past, except now we're storing it in a variable created with the with command. So now I can simply do the same thing, f.write, and write whatever I want to the file. Then I don't have to do anything else. All of that information is simply handled with the indentation of the with command. It becomes kind of like its own function. So now I'm just writing in there, and then it's closing automatically when the indentation ends. Now our entire file is working as intended, but instead of having all of that clutter of different files and of having to create the file variable and having to close the file, we're simplifying it to essentially just one line of code. Obviously, there are more complex things we can do with this, but that is the essence of files and the with command. So now for a brief challenge. So here is a text file that simply says apple. What I want you to do is read the data from the text file. It can be anything, but make sure that you're actually reading the code itself. Then reverse the string. Completely change the string so apple becomes ELPPA instead of APPLE. Thus, when you do that, I want you to write that reversed string back to the file. So if the initial input of the file is apple, I want you to return back to the file and overwrite the word apple with the reverse of apple. Note, you should try and use the with command or the with keyword whenever you can in this little sample problem. I'm going to give you a second to do that, and when we come back, we can talk about the solution. So the solution to this problem is actually really simple. All you have to do is first, with the with command, if you want to, read entirely from the file the data and store it in a variable called x. Then you can use Python list splicing because technically strings are just lists of chars. So with that, you can do that and then write at the variable is equal to the variable with the splicing. So with the splicing, all you have to do is colon, and then -1. That will return the reverse of the Python list. With that, you can use again the with command and write back to the exact same file what you just stored in that variable. After that, you're done. It works and it reverses the string. Now with file inputs, so you can even handle larger scale inputs with these. That's the beauty of files. You can handle so much more data and store your data for a longer time. That's why it's important to incorporate files into our programming repertoire. That's all for now, folks. I hope you enjoyed and I hope you learned something. If you did, make sure to leave a like, and if you want to continue your computer science journey, make sure to subscribe. That's all for now. Hope you enjoyed, and thanks for watching.